Okay, trig identities B, assignment number 1. So we're trying to prove this equals this. Okay, so I'm going to use the strategy of substituting ratios that I know. So cosecant is the reciprocal of sine. There's nothing I can do. Cotangent, okay, that would be the cos and divided by a sine. There's the substitution. And if I times those, I end up with the left-hand side equals the right-hand side. Okay, so I'm going to use the same strategy here on number 2. I'm going to substitute all the ratios that I would know. Okay, so sine angle times secant is 1 over cos angle, and cotangent is a cos angle over a sine angle. So you can see I would get sine angle cos angle over cos angle sine angle, right? Which I could have done this in the step above, but I can show you that everything crosses off, cancels, and you get 1. So therefore, I can state that the right-hand side equals the left-hand side. Do you notice that I use x's here and thetas here? Because that's what I was communicating as the original question stated. Okay, in number 3. Okay, sometimes you have to think which side to start from, more complex side, which these are kind of both the same. So I'm going to start with this one. Cosecant is the same as the reciprocal of sine. Okay, so if I put this over the common denominator, I would have to times this by sine. So if I times the top by sine, it would become sine squared, okay, which is 1 minus sine squared all over a common denominator. Okay, now I'm going to go into my identities here. I can see that if I move this around, 1 minus sine squared from this sentence equals cos squared. Okay, now I think I'm going to stop that side, and I think I'm going to work from this side to see if I can substitute in and get the same. So cotangent I'm going to replace with cosine over sine. And then when I times, I get cos squared theta over sine theta. And now I have my right-hand side equal to my left. Okay, so I'm going to think about the strategy on this one. You could work from the left or the right, I think. I'm going to show you working with the left. Okay, so if I wanted here, I could split these back into 2 fractions. So sine angle over sine angle plus cos angle over sine angle over the common denominator, and I added so I could split those. So now this side would be 1 plus, and this ratio is cotangent theta, and then I would be done. Okay, if I wanted to have worked from this side, I would have substituted in for cotangent. So that would be cosine theta over sine theta. Then if I'm going to add, I need to make them the same bottom. So they would both need to have a denominator of sine angle. So I need to turn this into a sine angle as well. And you can see that I'm getting sine theta plus cos theta all over sine theta. And then I would be done. Okay, next one. Okay, I'm going to start on this side because it looks more complex than that side. Okay, so I'm going to distribute this. So cos theta tan theta plus cos theta cotangent theta. Now I'm going to substitute what I know for ratios. So cos theta, tan is going to be sine theta over cos theta. Plus, and then I'm going to substitute for cotangent. So that's cos theta over sine theta. Okay, so now I think I'm going to factor out a cos theta actually. Maybe I didn't need to do that at the start because I'm seeing not the best right now. Okay, so I'm going to factor that out. Sorry, you could have done this at the start or not distributed. So sine theta cos over cos plus cos theta over sine theta. Okay, now I'm just going to work with this, trying to combine it. So that would mean a common denominator. Okay, so I would have had to times this fraction by sine theta, common denominator. So do you see how from here to here I times by sine theta? So I need to times the top by sine theta. And here I would have to times this fraction by cos theta. So this gets times by cos theta. Now I can see that I have a value of 1 here. Okay, so from there I can cancel that and I get 1 over sine theta, and on this side I could state 1 over sine theta as a replacement for cosecant, and then I'm done my identity. QED means done. I've proved it. Okay, number 6. So this I would FOIL. So it's a difference of squares when I FOIL it. 1 minus sine t plus sine t would go away, and minus sine t squared. So when I look in to my formula sheet, it's this one, so I can replace it. So I can replace it with cos squared t. And so this one I can go 1 over, and secant is the reciprocal of cos, and reciprocating that reciprocal back ends up getting you to cos squared. Okay, next one. So when I see these ones, when I see a 1 minus cos t, I often think of a conjugate. So I'm going to work from that side. So a conjugate is that I'm going to multiply it by 1 plus cos t. So I'd have to do the same on the top. When I multiply conjugates, so just like here, it creates this difference of squares. So 1 minus cos squared t. Okay, I'm just going to leave the top as is because I don't see any where that I'd go with distributing those. Okay, looking ahead, this is kind of why I thought to leave it, because I'm going to be turning this into using this. 1 minus cos squared would be sine squared. So this can be replaced. And then I can cancel a sine t out of the top and bottom. So I get 1 plus cos t over sine t. And now I've got the right hand and left hand sides equal. Okay, next one. So look for the more complex side, and I'm thinking it would be this side. Okay, so let's move these into sines and coses. So sine t over cos t plus cos t over sine t. I'm just going to leave this for now and see what happens. Okay, so this part right here, I'm going to try to get into the same denominator. So cos t sine t. So if I did that, this first fraction would have to get times by a sine. So the top would become sine squared. This fraction would have to get times by a cos t. So I'd have to make this cos squared on the top. This value can be replaced with this identity. So 1. Okay. Now if I distribute that through, I get cos t over cos t sine t, and plus sine t over cos t sine t. Cos t's can cancel, so 1 over sine t. Sine t's can cancel, which makes 1 over cos t, which this would become cosecant t, and this is secant t. And now I have the left-hand side equal to the right-hand side. Okay, question 9. So which side looks more complex? I would say the right-hand side. Okay, so I'm going to go with the strategy of seeing this and trying to conjugate multiply. So the conjugate would be 1 plus sine x, but then I'd also have to do that to the top. Okay, for now I'm just going to leave the top, but I'm going to simplify the bottom. So 1 minus sine squared x when I FOIL it. Okay, now 1 minus sine squared x can be replaced with cos squared. So I'm leaving the top. I can replace the bottom with cos squared x, and I can cancel a cos out. So I get 1 plus sine x over cos x. So here I could go with splitting the fractions. So 1 over cos plus sine over cos, I could do that. Or I can also, remember that I can work from the left-hand side. So secant can be replaced with 1 over cos x, and tan sine x over cos x. So that makes 1 plus sine x all over a common denominator of cos x. Now they're equal. Left-hand side equals right-hand side. Okay, let's see here. Thinking ahead, probably going to be replacing this. Okay, so I'm going to go tan theta sine theta all over sine squared theta. Okay, because 1 minus cos, I get that from here. Okay, so, should we cancel sine and see where we would go? So sine and sine, so I get tan theta over sine theta. Okay, I think I'm going to work a little from the other side. So cos theta plus tan gets replaced with sine over cos. Okay, now I'm going to multiply here, so I get sine squared over cos. Okay, now I'm going to make this all over one denominator, so I'd have to turn this into a cos. So if I turned that into a cos on the bottom, I would have to multiply the top by a cos. And this is an identity. So I'm going to use that. So 1 over cos, or I'm not sure where I'm going to get to here. I can go secant, but I'm not sure where I'm going to get to in here. So I'm going to keep going on this one. So tan is sine over cos. And then if I divide it by a sine, right, it would be the same as multiplying by 1 over sine, which gets rid of that, which turns into 1 over cos, and then I can stop. QED, I proved it.